elements of the list and try to force every single element to be reordered, confirm their sortedness. Right? That is the difference between the adaptive sorting algorithm and the non-adaptive sorting algorithm.
Somehow the sorting why
Then we'll consider about what is a sorting algorithm. If we take this, already you know what is what is an algorithm. Here we are dealing about the sorting algorithm. If we take the sorting algorithm, it will put elements of a list in a certain order. Then we have popular sorting algorithms. One is called insertion sort. Then the other one is called as selection sort. Then bubble sort and shell sort. These are some of the popular sorting algorithms. Have you heard about these sorting algorithms before? Give me an answer.
No, madam.
No. I have another question. Are you familiar about these flow charts and pseudocodes? Flow charts?
Yes, madam.
In level 5, I hope I have seen that in the curriculum, level 5 curriculum, in when you are at level 5, you have to learn the flow charts. I hope that you have done it in the College of Technology or in A levels.
Yes, madam.
Huh? Yes or no? Have done or not?
Level 5 student done, madam.
Okay,
In the
done.
A level students haven't done.
Madam, there are, I think they have basic knowledge. Because NVQ has got a deeper knowledge, but A level syllabus has no deeper flowchart concept.
Then what about pseudocodes?
I think that one also same.
Same.
For the level 5 students, pseudocodes have they studied, but A level students they haven't studied. Is that so?
Yes, madam.
Right. Anyway, right. Then you are not familiar about these terms. Therefore, no point of asking this. The next question. I wanted to ask you to name another sorting algorithm, but if you are not familiar with these things, then no point of asking that question from you. Right. Then we'll move on to the slide. Then consider the first sorting algorithm, that is insertion sort. Then as we studied earlier, this is called as in-place comparison sorting algorithm, right? Then what is an in-place comparison? We have studied about this thing in this slide. It means that algorithm doesn't require any extra space for sorting. Then the sorting will take place in the same location. Then here we have a sublist. Sublist is maintained, which is always sorted. As an example, the lower part of an array is maintained to be sorted. Then an element which is to be inserted in the sorted sublist has to find its appropriate place, and then it has to be inserted there. Then in this insertion sorting, there is searched sequentially. That means one by elements are searched one by one, and unsorted items are moved and inserted into the sorted sublist. Within brackets, it says in the same array. That's how it becomes in place comparison. Then this is not suitable for large data sets, as its average and worst case complexity are of 0 and squared. Then n is the O n squared, right? Here it's O n squared, where n is the number of items, right? I have given this worst case and complexity of algorithms in the first presentation. I have given you this basic idea about these things. Anyway, you have to keep in mind that this is not suitable for large data sets. And we'll move on to the next slide. I have shown you the graphs about this complexity, and O n squared, the graphs I have given. Then we'll continue from the previous one. Then every repetition of insertion sort removes an element from the input data, inserting it into the correct position in the already sorted list until no input elements, right? Then the array is searched sequentially, element by element. Then every element is put into the correct position until there are no input elements are remaining to be sorted. Then the choice of which element to move from the input is arbitrary. Then insertion sort is one of the fastest algorithms for sorting very small arrays. Then if the array is small, then insertion sort will give you a fastest result. Then we'll see how insertion sort works. We'll take an unsorted array. Any problems? If you have any problems, you can ask. No. Then this is the unsorted array, and it's having how many elements? 2, 4, 6, 8. 8 elements are there. Then the first element is 14, 33, 27, 10, 35, 19, 42, and 44. Then in the insertion sorting technique, it will compare the first two elements. First two elements are the 14 and 33. Then it will find that both 14 and 33 are already in ascending order. They are in ascending order. Then 14 is in unsorted sublist, right? Then after checking the first element, the insertion sort, first two elements, the insertion sort moves ahead and compares the next two elements. What are the next two elements? They are the 33 and 27. What can you say about these two values? Are those in sorted order or not? When we compare 33, 33 is higher than 27.
Sure.
They are not in sorted manner. Then it finds 33 is not in the correct position. Therefore, it has to swap these two values. Right? Have you heard about swapping? Swapping means what?
Put, changing two variables value from one to another.
Changing two values. Changing, yes, two values. Then if you swap, have you written any programs for swapping using C++?
Mm,
Huh?
in university, we didn't wrote, madam.
I mean, right? Right, in the memory, this is not relevant to this drawing, but if you write a program for swapping, then how do you take the value in a program?
Declare into a variable.
You have to declare a variable and assign the value to that variable, or you have to declare the variable and get the value from the user, right? If you want to, swapping is interchanging these two values. Then if you want to change these two values, what do you have to do?
We have to create another variable to keep one variable's value not permanently.
Right. You have to take an extra variable to have the values temporary, right? Then you can create an empty space and transfer. If we take these two values as left and right, now we'll consider 33 as the left value and 27 as the right value. Then you want to swap these two values, then you have to get an extra space. So a variable, we'll call it as temp. You have to move the value 33, the temp, then you can pass the value 27 to the location of the 3, then temp's value will be transferred to the right position. Right? That's how it works. Then it says it swaps 33 with 27. Then it also checks with all elements of the sorted sublist. Sorted sublist was having only the value 14. Sorted sublist has only one element called 14 and 27 is greater than 14. Therefore, no change is required. Hence, the sorted sublist remains sorted after swapping, right? Because 14 is less than 27, nothing happens in the sorted sublist. Therefore, the values will interchange easily, right? Then we'll move on to the next slide. When by now 14 and 27 in the sorted sublist, then next it will compare 33 with 10. Then again you can see that these values are not in a sorted order. Again it will swap them. Then the swapped list will be 14, 27, 10, 33. Then swapping makes 27. swapping, swapping makes 27 and 10 sort. Therefore, again you have to swap them. Then 14, 27, 10, 33, 35, 19, 42, 44. And because these two values 27 and 20, 10 are not sorted, then it will swap. Then the result will be 14, 10, 27, 33, 35, 19, 42, 44. Then you can see after swapping, earlier you had to swap 27 and 10 because in the sorted sub list these two items were not in a sorted manner, then 10 will come before 27. Again, in the sorted sub list, 14 creates the problem because 14 is higher than the 10. Therefore, again, you have to swap. Then by the end of third iteration, you will have a sub list of 4 items. Right? Then they are 10, 14, 27, 33. Right? That's how the insertion sort works. And this process goes on until all the unsorted values are covered in a sorted sublist. Right? That's how it works. Is it clear? Any problems?
Yes, madam. Is this same like the bubble sort method?
No. Bubble sort is a different technique, and when you are learning that, you can study that there are several. Usually, we call them as passes. Several stages will be there. That's why different sorting techniques are given. This insertion sort is ideal for a small list, small number of elemented lists. Why do we? What is the reason behind that?
Because if there are many numbers, it will take too much time to process this sorting.
Because here we are talking about a sorted sublist. When you swap the values, the sorted sublist also becomes unsorted. There are possibilities. In that case, when the number of elements becomes larger and larger, there will be so many iterations or the so many swappings will be there. It's not good for a large list, right? Then we'll move on to the next slide. That's about the algorithm. Insertion sort algorithm. Take the algorithm. Step 1. First step, we can say that, right, we were talking about this insertion sort algorithm. Then the first step 1. If it's the first element, it's already sorted, right? First element is already sorted, then we can turn 1. In the step 2, pick next element, then compare with all elements in the sorted sublist. Shift all the elements in the sorted sublist that is greater than the value to be sorted. In the step 5, insert the value, repeat until list is sorted. Right? That's how you can write the algorithm in a simple manner. Then actually, then you can write a program for this. This is the implementation in C or C++. you have to declare an array, then write some methods. Right, void print line, pass the variables and check. Now, when you look at this array, you can see that the values are not in the sorted position. Then after that, you can, after this program, after running this program, the array should be in a sorted manner. Right? That's how it arrays. For the arrays, I hope that you have written programs in C++. Programs කියලා තියෙනවනේ arrays වලට. Creating an array in C++.
Yes, madam. Yes.
Right. Then the thing is, you have to. Actually, programs are easily you can find from the web as well for the sortings. The most important one is you should have the idea of the operation array in insertion sort. Always compares two values, right? That means always it compares two adjacent values when you are sorting the unsorted array. And, in the sorted sublist also it will compare values 2 by 2, but the linear manner you have to move from the beginning to the end. Then in after sorting that you have to consider about the sorted sublist as well. The basic idea behind this insertion sort. Then there's an animation I think I have downloaded from the internet, right? This is just an animation. This is another example. Earlier I have given this in with drawings. Now this animations shows how the values will change, right? Right, then that's about the insertion sort. Right, that is about the insertion sort. Then next day, I will be discussing the another at least two sorting techniques, because usually when I'm doing this sorting in the classroom, you have to draw the diagrams, but in online session you will not have that chance of drawing the diagrams, but in your own you should try to draw the diagrams. Now you can remember the given array. I have given you the array. Then some of the elements are, according to my memory, some of the elements are yet to be sorted, right? Therefore, try to sort it this knowledge, right? Then for your exam, you will have the questions. In the past papers, I have given the questions. So the motion diagrams, the array, that means sorting diagrams. The array is sort, right? Then that's the end of the insertion sort. Then we'll wind up for today. If you have any questions, you can ask now. Then we'll stop for today.
Thank you, madam.
Thank you, madam.
Welcome.